Hey everyone, welcome back to the channel. Today we will be taking a deep dive into Azure's default routing behavior and system routes within virtual networks or VNets. This topic is essential for any cloud architecture or DevOps professional looking to understand how traffic is routed in Azure environments by default and how we can customize it for more advanced scenarios. When you deploy virtual machine workloads into Azure VNets and other subnets, a default routing behavior automatically takes control unless you have explicitly configured custom routes. This default behavior is governed by Azure's predefined system rules, which are associated with each subnet via a default route table. These system routes define how traffic should be routed internally within the VNet, as well as how to handle traffic moving to external networks and services. Let's start by breaking down the default route table, which contains 18 system routes. Each route plays a vital role in maintaining secure and efficient traffic flow. Azure ensures that your internal resources communicate smoothly while preventing unwanted traffic from exposing itself to the public internet. The first route is the default route table handles traffic between subnets within the same VNet. The next hop type is set to virtual network, meaning traffic destined to another internal VNet address will be routed through Azure's internal backbone. For example, let's say we have a virtual machine web VM located in the web tier subnet trying to communicate with other VM. It is the data VM located in the data tier subnet. The traffic will be routed through the default gateway of the web tier subnet and forwarded across the VNet infrastructure to the destination subnet's gateway, ultimately reaching data VM. This internal routing is seamless and secure, leveraging Azure's backbone for fast and reliable communication. The second route defines what happens when traffic doesn't match any specific route. The default route. In this case, the next hop type is set to internet, and this sends any unmatched traffic to Azure's internet gateway. It's worth noting that Azure has a smart routing mechanism. Traffic to Azure services with public IP addresses doesn't go over the public internet. Instead, it stays on the Azure private backbone, ensuring lower latency and enhanced security. Azure follows standard industry practices regarding private IP spaces. Traffic with destination addresses from private IP ranges is specified by RFC 1918, such as 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.0/16, won't be routed to the public internet. Instead, these routes have a next hop type set to none, meaning that traffic is dropped. This is crucial for ensuring that private internet traffic is confined to the VNet and never leaks onto external networks. A similar rule applies to addresses reserved for carrier grade NAT RFC 6598. Traffic destined for these addresses is also dropped, with the next hop type set to none. This ensures that internal traffic using carrier grade NAT ranges never leaves the VNet environment. Finally, Azure Management public IP ranges are protected from exposure through a similar routing rule. Traffic that targets these IPs is dropped, ensuring that Azure's internal management traffic is isolated from customer resources. This ensures platform integrity and secure communication channels for Azure's core services. In addition to the default system routes, Azure dynamically adds route based on certain networking configurations, such as VNet peering, VPN, and express route gateways and service endpoints. For VNet peering, Additional routes are automatically created for paired VNets, ensuring seamless traffic flow between them. For VPN and express route gateways, when a VNet is connected to an on-premises environment, the routing table will automatically include the necessary routes to direct traffic to the VNet gateway. Lastly, for the service endpoints, when service endpoints are enabled for services like Azure Store or Azure SQL, traffic destined for these services will be routed over the Azure backbone rather than the public internet. So in this walkthrough, we have covered the fundamentals of Azure VNet routing and how Azure's system routes ensure efficient and secure traffic flow. Understanding these system routes help you build better cloud networks and empowers you to customize your routing to meet specific application or security requirements. If you found this video helpful, don't forget to like and subscribe for more deep dives into cloud architecture and DevOps solutions. Thanks for watching, and I'll see you in the next video.